Often problems that do not appear to involve complex numbers are nevertheless solved most elegantly by viewing them through complex spectacles. In this video, we will illustrate this point with a geometric example. Consider a quadrilateral, a four-sided figure, seemingly simple yet full of mysteries. On each side of our quadrilateral, we construct a square. We then construct line segments joining the centers of opposite squares. As this picture now strongly suggests, these line segments joining the centers of opposite squares are perpendicular and of equal length. It would require a great deal of ingenuity to find a purely geometric proof of this surprising result. So instead of relying on our own intelligence, let us invoke the intelligence of the complex numbers. Introducing a factor of 2 for convenience, let 2a, 2b, 2c and 2d represent complex numbers running along the edges of the quadrilateral. We have chosen the origin of the complex plane to be at the vertex where 2a begins. Notice that the sum of 2a plus 2b plus 2c plus 2d equals 0 since we start at the origin and end at the origin. This implies also that a plus b plus c plus d equals 0. To reach the center P of this square constructed on the upper side, we go along a, then an equal distance at right angles to a. Thus, since IA is a rotated through a right angle, P equals a plus IA, which equals 1 plus IA. The complex numbers a equals s minus q from q to s and b equals r minus p from p to r are therefore given by these expressions. We wish to show that a and b are perpendicular and of equal length. These two statements can be combined into the single complex statement b equals ia, which says that b is a rotated by pi over 2. To finish the proof, note that this is the same thing as a plus ib equals 0, the verification of which is a routine calculation.